Assalamu alaikum students. Hope you all are fine and enjoying your studies at home. You are listening to your chemistry teacher, Miss Anna Islam, and today we are going to study through online support program OSP. Your level is 9 and 10 and your class is 9th class. Textbook Chemistry Grade 9 National Book Foundation, page number 14. Chapter unit number is 1 Fundamentals of Chemistry. Topic and lesson is Self Assessment 1.3, 1.4, Molecular Mass and Formula Mass. Resources required are laptop, tab, smartphone, internet. Introduction and summary of the lesson is this topic is about self assessment 1.3 and 1.4 and your molecular mass and formula mass, and you can see the picture of your textbook of grade 9. Here self assessment 1.3. In the self assessment 1.3, you have been given an aspirin is used as a mild painkiller. There are 9 carbon atoms in aspirin, 8 hydrogen atoms and 4 oxygen atoms. Once again we can read it: 9 carbon atom, 8 hydrogen atom and 4 oxygen atom in this compound. Write its empirical and molecular formula. Let's have a look. C means carbon. It has 9 atoms, hydrogen 8 atoms and oxygen 4 atoms. The empirical and molecular formula will be the same due to the simplest atomic ratio. Whenever we look at the formula, it means it has already a simplest ratio. So their empirical and molecular formula is same. In the question number 2, you have been given a 5% vinegar. In vinegar, there is a 5% of acetic acid. This contains 2 carbons, 4 hydrogen atoms and 2 oxygen, as we did in the first question. We have to do the same thing, empirical formula and molecular formula. So, how many carbons have been given? 2. Hydrogen are 4 and oxygen is 2. Again, your molecular formula will be C2H4O2, and when we divide it by 2, because the only table of 2 goes to all 3 digits, 2, 4, 2. So, empirical formula, as you know, will be the simplest ratio. And when we come to the simplest ratio, it means 1 to 1. That is the simplest ratio, CH2O. This is the simplest ratio. Okay, now in question number 3, you have been given caffeine. You know it has a formula C8H10 and 4 and oxygen 2 and stand for the nitrogen. Is found in tea and coffee, you know very well. Write the empirical formula for the caffeine. We will write C8H10, nitrogen 4 and oxygen 2. So molecular formula will be your C8H10 N4 and O2. You can see we can divide them 2 to get the simplest ratio. So its empirical formula will be C4H5N2O1. It is its empirical formula. Now come to the molecular mass and formula mass. As you know, the molecular mass and formula mass is the sum of atomic weights of the atoms in the molecules molecular formula. Formula mass is the sum of the atomic weights of the atoms and the molecules empirical formula. Okay? Whenever we come to your book, your textbook, you will see a page of like this on page number 14. You can see that molecular mass and formula mass is the sum of atomic masses of all the atoms. Molecular mass is simply the sum of all the atomic masses present in a molecule. When we sum up them, we will get what? Molecular mass. For example, in H2O, it is the molecular mass of the water, and when we calculate it, we will get 18 AMU. As you know, the atomic mass of hydrogen is 1 divided multiplied by 2 plus 16 oxygen atomic mass, we will get 18 AMU. In the same way, when we are coming towards this one exercise, you can see that in this one you have been given different kinds of formula masses. At the sum of the atomic masses of all the atoms in the formula unit of the substance, it is called your formula mass. Usually, you have to memorize that formula mass stands for normally for the salts. Like in this picture, you can see the formula mass of NaCl and magnesium hydroxide. The formula mass of sodium chloride is 58.5 AMU, whereas magnesium hydroxide is 58 AMU. Okay, now we are coming towards self assessment 1.4. When you look at the self assessment 1.4, you have been given potassium chlorate is used as for the laboratory preparation of oxygen gas. We have to simply find out its formula mass. Potassium chloride. You know the atomic mass of potassium is 39, chlorine is 35.5, and oxygen is 16. As we use 3 atoms of oxygen, we will do what? We multiply 16 by the 3. 39 plus 35.5 plus 48. You will get 122.5, 122.5 AMU. When you coming to the baking soda, you know very well the baking soda is used into the biscuits and in cookies and bread for the baking purpose. We have to find out its the formula mass of the baking soda and carbon dioxide, formula mass of sodium bicarbonate or baking soda. It is the formula of the baking soda, sodium hydrogen carbonate or sodium bicarbonate. 23 plus 1 plus 12, 3 multiplied by 16, we will get total of 84 AMU. This is the formula mass for the what? Sodium hydrogen carbonate baking soda. Formula mass of carbon dioxide is so simple, 12 carbon plus 32 oxygen atoms. We will get 44 AMU. Now in the question number 3, following compounds are used as fertilizers, determine their formula masses. We have to find their formula masses. As you know, urea is diamine carbonate and aluminium nitrate is your NH4NO3. Aluminium mass of urea NH2 urea. Formula mass of urea is your NH2 diamine carbonate and we will get it 60 AMU. And ammonium nitrate by 14 plus 4 multiplied by 1 plus 14 plus 3 multiplied by 16, we will get total of 80. Now, students, is your assignment number 4. You have to find out the molar masses, the molecular masses of the following chemicals: chlorine atom, potassium hydroxide, barium chloride, iron chloride, boron trifluoride, carbon dichloro, difluoro, and we can say that dichloro, difluoro, methane, magnesium hydroxide, and sulfur dioxide, phosphoric acid, and your ammonium sulfate, acetic acid, PB nitrate, and your gallium silicon trioxide, sulfur trioxide. Thank you so much. Stay blessed. Allah Hafiz. Take care.